Hello everyone, myself Rakshit Goda from CMR University. I am doing this video for my assignment. Let's talk about programming in C. C programming is a versatile procedural language which was developed by Dennis Ritchie at Bell Labs, used for creating system applications that interact directly with hardware. It's often called the mother of programming languages because many other languages including C++, Java, JavaScript and Python have borrowed from its structure and syntax. C is known for its efficiency and flexibility, making it suitable for low-level programming tasks like operating systems and device drivers. C programming is a level language. Here are some key aspects of C programming. Low level access. It allows programmers to directly manipulate hardware and system memory, providing fine grained control. Its efficiency. C is compiled into machine code, resulting in fast execution and memory management. Versatile. It is used in diverse applications including operating systems, embedded systems, game development, and many more. Now we talk about the operators in C program. Arithmetic operators. Here we take x value as 40 and y value as 20. Operators. Addition. Its symbol is plus and examples are x plus y. 40 plus 20 is equals to 60. Subtraction. Minus symbol. 20. Multiplication. Star symbol. Its value is 80. Division. Slash symbol. Its value is 2. Now, relational operators. Lesser than. It shows that left side is lesser than the right one. Lesser than or equals to. It shows that left side is less than or equal to the right one. Greater than. Left is greater than the right one. Greater than or equals to. It shows that it is greater than or equal to the right one. Double equals to. It means left side is equals to right side. Exclamatory is equals to. It means that it's not equal to. Logical operators. Double and. Its meaning is and. Double slash or exclamatory not. Now bitwise operators. Bitwise and assignment. It performs a bitwise AND operation between the left and the right operands and assigns the result to the left operand. Bitwise next. Bitwise or assignment performs a bitwise or operation between the left and right operands and assigns the result to the left operand. Now bitwise XOR assignment. It performs a bitwise XOR operation between the left and the right operands and assigns the result to the left operand. Lesser than equals. It tells that left shift assignment shifts the bits of the left operand to the left by the number of positions specified by the right operand and assigns the result to the left operand. Right shift assignment shifts the bits of the left operand to the right by the number of positions specified by the right operand and assigns the result to the left operand. Now we talk about the pointers. It's what is pointers? A pointer is a variable that holds memory address of another variable where the actual data is stored. It's when declaring a variable, the compiler sets aside memory storage with unique address to store that variable. The compiler associates the address with the variable names. We can give some different variables by using alphabets. When the program uses the variable name, it automatically accesses a proper memory location. No need to concern which address, but we can manipulate the memory address by using pointers. Let's say we declare a variable named nrate of type integer and assign an initial value as follows: int nrate equals to 10. Hashtag, hashtag include stdio.h void main in the bracket void op- in the braces int nrate is equals to 10. Printf variable name is nrate. Print size of a nrate int is modulus d bytes slash n. Size of nrate. Print size of the short int is modulus d bytes slash n. Size of short int. Print initial value stored at n rate is modulus d slash n comma n rate. Printf memory addresses of n rate is modulus p dot slash n comma n rate braces close. Now when we execute the program, we will get output as this one. The variable is stored at a specific memory address and can be depicted as follows. Here it shows example. Here we give nrate value as a 10. It's reflecting here. Nrate value, current stored value it is. And nrate 10 is a current stored value. Nrate is a variable name. The variable scope is local to the main brackets function. The memory allocation is from the main function's stack. The nrate memory address or any other variable is a number, so can be treated like any other number in C. Using percentage %p, the address in the hexadecimal format. Hence, if variable's memory address is known, we can create a second variable for storing the memory address. From the previous example, let's declare another variable named p10rate to hold the address of nrate variable. At the beginning, p10rate is uninitialized, so storage has been allocated for p10rate, but its initial value is undetermined as shown below. Now see here p10rate's value is uninitialized because we didn't assign the value. So the pointer variable declaration becomes something like this: int star p10rate. In the word, the p10rate variable holds the memory address of nrate and is therefore a pointer to nrate. By using these pointers, it is an efficient way of accessing and manipulating data. Very useful for dynamic memory management. As we know, memory registers and cache or scratch resource in computer system. Every computer system, there are fixed and limited amount of memory for temporary data storage and processing. There are loading and unloading data into and from, moving data from and to different locations of the memory, including the cache, the processors registers for temporary data storage and processing. The loading and unloading need an efficient memory management. Some of the memory portion also used for shared data to further optimizes the utilization. This shared data accesses depend heavily on the pointers manipulation. Without moving, loading, unloading data to from different locations in memory, we can use pointers to point to different locations. By using pointers, we can shift the memory from one point to the another point or different locations. Pointers and simple variables. A pointer is a numeric value and like other variables must be declared and initialized before it can be used. The following is a general form for declaring a pointer variable. Type of store data. Star pointer underscore variable underscore name semicolon. For example, is there type of stored data is any valid pointer based type such as char, int, float, or other valid C derived types such as an array and struct. It indicates the type of variables data to which the pointers is pointed to. From the pointer declaration examples, in the first line, the declaration tells us that character name is a pointer and to a variable of type char. The ask is an indirectional operator and indicates that character name is a pointer to type char and not a normal variable of type char. Note the position of the star, it is valid for all the three positions. Pointers can be declared the along with the non-pointer variables as shown below. Now, how to initializing pointers. Once a pointer is declared, we must initialize it. This makes the pointer pointing to something. Do not make it point to nothing. It is dangerous. We need to give some data after initialization. Uninitialized pointers will not cause a compiler error, but using an uninitialized pointer could result in unpredictable and potentially distressed outcomes. Until pointer holds an address of variable, it is not useful. C uses two pointer operators. In directional operators, it has been explained previously. Address of operator ampersand symbol means return of the address of. When an operator is placed before the name of the variable, it will returns the memory address and variable instead of storing value. Program example initializing a pointer. We can see this example. In this example, pointer variable p payload receives the address of n location, or the memory address of n location variable is assigned as ptol pto int pointer variable. From the previous example, we if we declare another, see graphically this situation can be illustrated as shown below. The operator is complement and of AND operator. From the previous example, if we declare another variable of type int another var int star pto int and is equals to and n location is equals to 100, then statement another var is equals to star pto int will place the actual current data value stored in variable n location into variable another var, which means another var was assigned the actual current data value stored at the memory address held by pto int. The star operator appears before a pointer variable in only two places: when declaring a pointer variable, when dereferencing a pointer variable, to show that the data it's pointed to. Using pointers we can do only the addition and subtraction operations are permitted in pointers expression. As with any variable, a pointer may be used on the right hand side of an assignment statement to assign its value of another pointer as shown in the following example. Here we assign pointers variable. For I pointer 1 we assigned as value 100, and for I pointer 2 also we assigned an value as 100. Normal variable comma I num is equals to 100. The num address is 0012FF60. For pointer arithmetic operation, only two arithmetic operations, that is addition and subtraction, available. For example, int I age is equals to 35. Hence, C reserved storage for the variable I age and store the value 35 in it. Let's say C has stored this value at the memory address 1000. Then we declare a pointer variable named p pointer to age that point to the I age variable. That then, after the following expressions have been executed, int star p pointer to age, example it's p pointer to age is equals to and I age p pointer to age double plus means it's increment. The content of the pointer then becomes 1004 instead of 1001. Integer value takes 4 bytes, so C add 4 to the pointer. Now, different variable types occupy different amount of memory. Implementation dependent following C standard or implementation extension, and whether 16, 32 or 64 byte systems. Each time the pointer is incremented, it points to the next integer, and similarly, when a pointer is decremented, it points to the previous integer. Each individual byte of memory has its own address. So, multi byte variable actually occupies several addresses. Next point, when pointers used to handle the addresses of multi-byte variables, the address of a variable is actually the address of the lowest byte it occupies. For example, int inum is equals to 12,252 colon double slash 4 bytes char character ch. For variable we use var is equals to 90 colon double slash 1 byte float f var is equals to 1200.156004. The pointer variables are pointing to the lowest byte of variable memory slots. Example, inum occupies 4 bytes and ch var occupies 1 byte. Other pointer arithmetic operation is called differencing, which refers to subtracting two pointers. For example, two pointers that point to different elements of the same array can be subtracted to find out how far apart they are. Next point, pointer arithmetic automatically scales the answer so that it refers to the array elements. Thus, if point p pointer 1 and p pointer 2 point to elements of an array, the following expression tells you how far apart the elements are. See example. However, ptr diff underscore t type can be used to return the subtraction operation between two pointers. For subtraction operation, ptr diff underscore t is the code. It is a base signed integer type of C/C++ language. The type's size is chosen so that it could store the maximum size of theoretically possible array of any type. On a 32-bit system, ptr diff underscore t will take 32 bytes. On a 64-bit, 164 bits. The ptr diff underscore t type enable you to write well portable code. Let's say we have declared a pointer something like this: int star iptr var semicolon. This statement declares a pointer to a type int but not yet initialized. So it does not point to anything known values address, such as it means that the address. Then consider the following pointer assignment statement. Star iptr var is equals to 121. You can see here how it has been executed. This statement means the value of 121 is assigned to whatever address bracket 00 question marks iptr value is pointing to. That address can be anywhere in memory which may contain critical data, and 121 stored in the location may overwrite some important information, and the result can be anything from program error to a full system crash. We must initialize a pointer so that it point to something. Do not create a stray pointer. Here the third point, the 121 stored in that location may overwrite some important information, and the result can be anything from program error to a full system crash. When we do the error in some information and some errors in the code, it will not be give the successful execution. A better solution, we can assign null value during the initialization before using it, such as int star iptr value is equals to null. For a pointer that point to a string, you may just point to an empty string for a dummy such as char star ch my string is equals to double slash semicolon. The .net c slash C++ programming uses null ptr instead of null. Null or null ptr is a pointer that points to the 0 into 000 32-bit systems memory address. It's one of the memory address. Null ptr is example for a null pointer and an empty string. When we give 0, when we initialize the value as a 0, see the I pointer is pointing to 0. The character my string pointer is pointing to 0. The ch dummy pointer is pointing to 0041576C. Now we talk about arrays and pointers. A special relationship exists between pointers and arrays. An array name without bracket is a pointer to the array's first element. So if a program declared an array char ch name bracket 10, ch name is an array's name, is the address of the first array element and is equivalent to the expression, and ch name, it means character name 0, which is a reference to the address of the array's first element. Ch name is equivalent to the and ch name. The array's name is therefore a pointer to the array's first element and therefore to a string if any. A pointer is a constant which cannot be changed and remains fixed for the duration of a program execution. When we initialize the pointer at the beginning of the program, we cannot change that value of the pointer uh, in the middle of the program while execution. Many string operations in C are typically performed by using pointers because strings tend to be accessed in a strictly sequential manner. Here is the example of the pointers and array. Enter a line of text. A simple line of text. Line of text is entered. A simple line of text. If we enter here some textings, it will be illustrated as follows. Arrays of pointers and function. Pointers may be arrayed like any other data type. For example, a pointer array I array ptr of size 20 is declared as int star I array ptr 20 within the bracket 20 to assign the address of an integer value called int var to the first element of the array. We could write something like this: I array ptr within the bracket 0 equals to and I int var. It is a graphical representation. To find the value stored in I int var, we could write something like this: I array ptr 0. To pass an array of pointers to a function, we simply call the function with the array's name without any index subscript, because this is an automatically a pointer to the first element of the array as explained before. For example, to pass the array named I array ptr to view array function, we use the following statement: view array function within the brackets I array ptr Graphically, the construct of a pointer to pointer can be illustrated as shown. I pointer 1 is the first pointer pointing to the second pointer, I pointer 2, and finally I pointer 2 is pointing to a normal variable I num that holds integer 0. When we give the value to the I pointer 1, it goes to I pointer 2, and finally I pointer 2 value goes to I num value. In order to indirectly access the target value pointed to by a pointer to a pointer, the asterisk operator must be applied twice. Tells compiler that I operator tells compiler that I operator 1 is a pointer to a pointer of type integer. Pointer to pointer is rarely used, but you will find it regularly in programs that accept arguments from command line. Here we can refer to the individual string by using PTO char pointer. PTO P to char pointer 1, and generally this is identical to declaring char star P to char pointer brackets. Or from last figure we can see from the last figure that char doubles star P to char pointer. Thus, programs that accept arguments through command line, the main parameter listed is declared as follows: int main, int argument char double slash arg or something like this. Int main, int argument comma character argument. So our main function now has its own arguments. As a convention, these are the only arguments main accepts. Notice the argument 0 is an application name. Argument counter, we represent it as argc, is the number of arguments which we input including the program name. Argv, it means argument vector, is an array of strings. Argv 0, argv 1, argument vector bracket 2, holding each command line argument including the program name, that is the first array element. But some implementation. Now null pointer constant. Null pointer constant is guaranteed not to point to any real object. You can assign it to any pointer variable since it has a type void. The preferred way to write a null pointer constant is with null character star p nul pointer is equals to null, or characters star p null pointer is equals to null ptr. Null pointer when set actually pointing to memory address 32 bits. The computer system have reserved this zero address for null pointer, and that is why it cannot be used for other purposes. Since C function can only return one variable, it is common practice for those which return a pointer is set to null can avoid the stray pointer. Set a pointer to null to indicate it's no longer in use. Void pointers and null pointers are same. There are times when you write a function but do not know the data of the return value. When this is the case, you can use void pointer, a pointer of type void. Other pointer declarations that you may find and can make you confused are listed below. Here are some pointer declarations and their description. What it means. Int star x. X is a pointer to int data type. Int star x bracket 10. X is an array within bracket 10 of pointer to int data type. Int star within bracket x within the brackets 10. X is an array within the brackets 10 of pointer to int data type. Int double star x. X is a pointer to an int data type double pointers. Int function star function braces is a function returning an integer pointer. Int function bracket star function brackets function bracket is a pointer to a function returning int data type. Int bracket star bracket star function brackets within the bracket 10 and brackets function brackets is a function returning pointer to an array 10 of pointers to the functions returning int. Thank you for watching this video.